Accessory organs of the skin develop from the embryonic epidermis and include the hair, the glands, and the nails. So hair and nails serve to protect the body. Sweat glands help to regulate body temperature. So we'll do just a brief discussion on each of these. So hairs are present on most skin surfaces except with the palms of the hands and the soles of the feet and the palmar parts of our digits. In adults, hair is most heavily distributed on the scalp, the eyebrows, the axilla or armpits, and around the external genitalia, though genetic and hormonal influences can largely determine the thickness and the pattern of hair distribution. The hair really doesn't protect a lot, but if you think about the way that the sun is coming down, and if you get a blow from something swinging toward your head, the hair can certainly help to protect the scalp from the UV radiation and from those incoming blows. It also helps us to keep heat in the body by preventing heat loss from the scalp. The eyebrows and the eyelashes protect the eyes from foreign particles, very much like the hair in the nose, and the external ear canal helps to defend those passageways as well. There are touch receptors that are located near the roots of the hair, associated with hair follicles, are activated when the hair is just very, very slightly moved. So if you think about feeling a tiny little bug land on the hair on your arm, that has to be detected and sent in through those nerve receptors. So hair provides more functions than we may think of. And very much like we saw with the epidermal cells that make up the skin, the hair is also composed of dead keratinized epidermal cells. When you look at a hair, there are three primary parts. What you see externally is the shaft of the hair, which grows from a follicle that's located below the skin, and it grows from a root that penetrates into the epidermis. So looking at a hair structure, you can see, of course, the hair shaft is what comes out. So here's the hair shaft. It is located within the follicle, and down in the follicle we have cells that are going to create new cells and new cells and new cells and push them further and further and further up as they accumulate and form a hair shaft. Now we're not going to go much deeper into that, just to understand the different major parts of the hair. We do have different types of hair throughout our lifespan. Lanugo is a very fine non-pigmented hair that covers the fetus. A lot of times a baby will be born and they look very hairy because they're still covered with that lanugo. Vellus is very short, fine, pale hairs that replace the lanugo, which some of that may eventually be replaced by terminal hairs. Terminal hairs are the longer, coarser hairs that are heavily pigmented, such as you have with your eyelashes and eyebrows and the hair on our head. And then even more of that vellus is going to be replaced when we have an increase in estrogen and testosterone as we near puberty, and that causes the hair in the pubic area to become very dark and terminal hair as well. Now, before we move into the glands, just in case you're wondering, hair color is primarily influenced by the particular amount and type of melanin that your melanocytes make. Graying of the hair occurs because we have a progressive decline in some of the enzymes that allow melanin to be made. And we talked already about some of the major functions of the hair being protection, helping us to keep or to decrease heat loss through the top of the head, and sensing that very, very light touch. As you age, hormones and environmental factors can influence the way that your hair grows and the way that you lose that hair. All right, so enough about hair. Let's look now at some of the glands associated with the skin. 4 types of glands. Sebaceous glands are oil glands that are going to be associated with hair follicles. So if we look here at the cartoony image, here of course is the hair follicle with the hair shaft growing out. There is a sebaceous gland. It's going to secrete sebum or oil onto the hair shaft. The eccrine sweat glands are the most numerous types of sweat glands. So here you would have a typical eccrine sweat gland. Your apocrine sweat glands are the ones associated with a hair follicle. I usually tell students to remember the difference in eccrine and apocrine, in that apocrine or apocrine makes you smell like an ape. So these are going to be located in the axillary and genital regions, so in the hairy skin areas. And then the ceruminous glands are modified sweat glands that secrete earwax into the ear canal. So on the next couple of slides, we've got some tables that will help you to understand the different functions and the different distributions of these glands. So sebaceous glands are the oil glands located in the lips, the glands penis, the labia minora, which is some of the labia, or one of the sets of labia associated with the external female genitalia. So these are going to be small glands located in the trunk and the limbs also, but they're absent in the palms of the hand and, of course, the soles of the feet. Why? Because there's no hair there, so there's no need to secrete sebaceous secretions or oil in those areas. Eccrine sweat glands are located throughout most of the body, so these are going to produce sweat that is very thin and watery, so this is the non-stinky sweat. The apocrine or apocrine sweat glands are going to be found in the axilla or the underarm area, in the groin, the areola, which surround the nipples, the bearded regions of the face, and associated with the external genitalia. So these are the glands that create a, you might say, stinky or odoriferous sweat. And then the ceruminous glands found only in the auditory canal, secreting earwax. So the functions of each of those: the sebum prevents hairs from drying out and helps to prevent water loss, also inhibits some bacterial growth. The eccrine sweat glands primarily are going to help regulate body temperature and get rid of waste products. The apocrine sweat glands are stimulated during stressful situations or sexual excitement and are thought to be the source of those chemicals known as pheromones. And ceruminous glands secrete that sticky, thick earwax so that things don't get into the ear canal. For instance, if you have a tiny little bug fly into your ear, they're probably going to get caught in the cerumen rather than getting into the deeper structures of the ear. Your nails are also an accessory organ of the skin and also made of keratinized, dead epidermal cells. The major structures, the part that is embedded in the skin or embedded in the dermis, is the nail root, and then you have a small little strip of tissue known as the eponychium, or what we commonly call the cuticle. The little moon-shaped structure is the lanula. The main part of the nail is the nail plate, and the free edge that is not attached to the finger that grows so long and extends off the end of the finger is the free edge. Makes sense, right? So the nails, again, being made of that dead keratinized epithelial cells, give a very protective covering to the tips of the fingers. They also allow us to grasp and to pick up small objects. So they're very useful until they grow too long, and then they can inhibit or keep us from being able to pick up small objects. All right, so the next couple of slides, you just have a comparison of thick and thin skin, where they're located, what they look like, and the layers that compose them. I'm not going to read slides to you because, hey, I know you're an adult and you can read. I just thought I would put this in there so that you do have these nice little tables giving you those differences and the things that they have in common. So here again, additional features comparing thick and thin skin.